Hi, in this video, I want to continue the machine learning using R series. And today I want to talk about how to implement the boosting from scratch. So we have three basic methods assembled, learning algorithms, bagging, boosting, and stacking. Okay. And first, brief overview of boosting. Boosting combines many weak learners to form a strong predictor. Okay. The key idea is each model fixes the mistakes of the previous ones. Um, the weak learners are simple models, example, shallow trees or stumps. And weights, misclassified sample get higher weight in the next round. Final prediction. Hello, in this video, I want to continue the machine learning using R series. I will talk about how to implement the boosting from scratch. So it's a quite long video, so I will go a little bit faster than usual. First, hello, in this video of machine learning using R series, I will talk about how to implement the boosting from scratch. So I have a lot to cover, so I'll speak faster than usual. First, a brief overview of boosting. So boosting is to turn many weak models into one strong model. Okay, it's kind of a very weird because bagging is relatively easy to understand. You bootstrap and then you train one model on each bootstrap sample, and then you aggregate them. So the core idea of boosting trains a sequence of simple models where each new model focuses on the mistakes made by the previous ones. So that's kind of how boosting works. Okay. And the weak learners, these are very simple models, often tiny decision trees called stumps that by themselves perform only slightly better than guessing. Okay. So it's kind of a miracle. Okay. So from weak learners, and then how boosting works. After each round, examples that were misclassified for predicted poorly are given more weight. The next model pays more attention to these harder examples. So there's a weighting process based on the misclassification errors. Okay? And final prediction, boosting combines all the trained models into one predictor by weighting each model's contribution. And there's the common types of boosting. You have adaboost, you have gradient boosting, and you have XGB boost and the related methods. And I will talk about how to implement these by using R packages as well. Advantages of boosting, it can achieve high accuracy even when using very simple base models. Works like a miracle. Okay. Disadvantages can be sensitive to noisy data and outliers. So it's good before you start maybe to check about the noises, the variability of the data, also check for outliers. Okay. And when to use it, great for classification or regression tasks where relationships are complex or nonlinear. Okay, that's the strength of boosting. Okay, let me show you in this video how to implement boosting, adaboost in R from scratch. So there's a couple of modules. Module one is to generate synthetic data, set random seed, sample size, and the predictors. Dependent variable is y, and to predict x1, x2. You can plot out the data points, so you can see the red and the blue dots. You want to separate them. And module two is you want to implement adaboost from scratch using decision stump. The stump is like a simple decision tree. So here we're using decision tree as the base. You can use other weak learners as well. So the decision tree, and if we're using like our package like our part, then we don't have to do this. Okay. So we write this decision stump. It's just gonna do like one iterations of the decision tree, and then just return the features, the threshold, and direction, and also error. Okay. And module 3 is so we do adaboost training function. Okay. So this is where you do the training when you're readying the data, and then you get to the initial uniform weights, and then you create a list of models and you specify the alphas, and then you make one decision stump at each iteration, and you calculate the errors, update the alpha, and then you update the models and the alpha, and then you can compute the predictions of the stump, and then update the sample weight. This is critical. So this is actually how why boosting works is by this weighting. You put more weights on the more misclassified models. Okay? And then you normalize the weights, and then you return the models and the alphas. So after that, module 4 is to adaboost the prediction function. So you have the training. Once you train the model, then you can use it for prediction. This is relatively easy. And since we are just doing a binary classification, so it's relatively simple here. And then you get this module 5, we train the adaboost and then evaluate its accuracy. First, we convert Y to numeric, positive 1 and negative 1, and then we separate the features and label them, and then we use that adaboost underscore train function to train it. For this small data set, it's really complete computation very fast. So then we use the adaboost underscore predict function to make predictions. Also very, very quick. And then we calculate the accuracy, which is the mean of where the prediction equal to the true value. Okay. And we got really high accuracy, 95%. Okay. And also module 6, this is optional, so you can actually plot out the decision boundary. This is gonna take a little bit longer time. Okay. It's rendering the image. Okay, now you can see it's colored. You see the nonlinear boundary there. So this is showing the advantage of boosting. So we get 95% accuracy for this pretty complicated nonlinear boundary. Okay. All right. Yeah, the purpose of this video is to really show you how to programming in R to implement adaboost. Hopefully, by doing this exercise, you'll get a better idea about how boosting works. And also, there are R packages which are readily available to implement different types of boosting algorithms. We'll do those later. And if you like this video, please click the notification bell so you get updated whenever I upload new videos. And also please subscribe to our learning channel and also share this video with other learners who may be interested. Thank you so much.